we just saw the while loop based solution for the shortest subarray problem reaching to a given sum. And now, I think the solution is very clean because, very, let's say, illustrative, because it tells us very clearly how the pointers are moving. And in every iteration, either move right or move left, and the, code, let's say, moves well. The broad principle is easy to understand that, look, if the current sum is less than the target, well, then expand the window because the numbers are positive. And if the current sum is more than the target, well, then contract the window because again, the sum, the numbers are all positive. However, the confusion points, and this is always the case in this kind of codes, is what do we do when the sum is exactly 8? Now, 8 or say the target, right? The approach that we have taken here is that, look, in this situation, if the sum is exactly equal to 8, I am going to expand the window. For example, over here, so my sum becomes 8. Now, at this point, I expand the window. My logic is that, look, my numbers are all positive. If I were to contract the window, I would have gone to say, for example, 141, which is 6, sum of 6. That will anyway force an expansion. So I'll go to 1413. So instead, because the sum will only decrease, right? So my logic is, okay, since we're already at the sum, let's expand the window, and then if needed, we'll contract. And that's exactly what happens, right? Um, now, now that is what is going on in our case. Notice my expansion happens when current sum is less than equal to. Now you notice that there is one more condition we have put in here, which is left equals to right. Now this primarily came to my, let's say, the main motivation that I put it in was that what happens if the very first sum is, let's say, more than 8, right? So let's say maybe 20 or something like that, right? Now in that case, I do not want the left window to be expanded because that will cause some, strange situation, left going above right. So that's why I put this over here. But basically what I found is that with this done, though the code probably is a little bit verbose, but I think it's very, very clear. And we can test this by actually putting an exact date. So let's just see, right? For example, if I put maybe 11 over here, so this is more than the target. Now when I run this, so you notice I do find my shortest window, which is, range 3 starting at index 4, which is basically 0, 1, 2, 3, 4. So this is the window, right? Now, because of this condition over here, when I find the very first value, in fact, I should be getting into else over here because sum is more than the target. But here I choose to expand because, like I said, I want to keep my window, always, let's say, meaningful. The corner case we are looking at is that if what happens if a particular current sum becomes exactly equal to the target. So let's test that as well. So I'm putting an 8 over here, let's say. So let's say if you had 8 in the beginning, in fact, I will find it. Reason is simple because, the very first iteration, I'll get into this loop and hence I will, record it, right? And that's exactly what happens when I find 8 in the beginning, right? Let's say I put an 8 in the middle and I make this, let's say, maybe 8, 12 or something like that, right? So it's more. Again, I will find it. Notice index range 1 starting at index 4 once again, because in the first iteration, this condition comes into play and makes sure my window expands. And subsequently, obviously, if I hit a current sum of t, I will go and record it. And the pointers move in a way that, look, the window expands if I'm more than t. Once it becomes equal to t, which is this, I just expand the window. So seems quite logical to me. And then finally, let's say we put an 8 at the very end. So let's say I change this and I put an 8 in the end. So that's my basically target here. If I look at this once again, it does find it. So here what's happening is, look, the right has increased all the way to the end, but then the chance for left to start increasing because the window keeps contracting. I find the window contracts at the last index, left and right are both equal. I do find that they are equal, and they're equal to the target, and hence, once again, this condition comes into play and I record, right? So it seems very logical to me. Basically, this here takes care of the corner case where the first number happens to be more, and subsequently the contraction expansion takes care. And basically, if I become equal to target, even if the 2 pointers are equal, I will, record it, right? So that's why I've done it this. But I thought I'll bring it up here because I have seen implementations where the sum, when it's equal to the target, the left pointer is expanded, right? But to me, this seems very logical and it's very clear to understand what's going on here, even if the code, let's say, is a little bit more verbose than some of the other codes, right? So, do look at it and do think about it. And if you think there's a corner case that I may be missing, I'm very happy to discuss. Please do highlight in the comments, right? So, very, very important to think through these details because it's these little details that make or break our code. Do look at our website www.ybyte.in for more such material and enjoy programming.